Good morning, class. Today what we're going to be looking at is the surface area of pyramids and cones. These are two shapes that we have looked at before, just briefly, but we haven't actually found their surface area. And just like before, the surface area is the addition of all the surfaces areas added together. So when I look at this is a pyramid. Why? Because it has one base and every other face is a triangle. So this is a pyramid because one base, every other face is a triangle. All those triangles meet at one point at the top, which I call the vertex of the pyramid. This is the base, the vertex of the pyramid. And the lateral faces are the faces that aren't the base. Again, a lateral edge is any edge that meets at two faces, lateral faces. And a base edge is where the base and the lateral face meet. Now, before with the cone and, not the cone, the cylinder and the prism, when I looked at the height of this, how far above the ground it is. So if I had it resting on the ground, how far above the ground it is, and the length along this edge were the same. So I didn't have any issue. But now when I look at this, the height of this is from my base here to the vertex. That's from my index finger to my other index finger. That isn't the length along this here anymore. So the height of my shape is different than what we call the slant height. The slant height is from the vertex to the base edge, and it's perpendicular. So the height of the pyramid is from fingertip to fingertip, vertex to the middle of the base, and the slant height is from the vertex to the base edge. For calculating surface area, the slant height is the one I need to use. If I have the height, I'm going to have to use a triangle to find out the slant height. Alright, so the first problem that we're going to be able to do is this. A regular square pyramid has a height of 20 centimeters and a base edge length of 30 centimeters. Find the area of each lateral face of the pyramid. So I've drawn my pyramid. It'll look something like this. This is the pyramid. This is the base down here, the square, and each side is a lateral face. Now, the slant height is what I'm going to need for my calculation here, and that's from here to here at a right angle. So if I would look very carefully, I see that if I connect this height, the slant height, with a line, I'm going to get a right triangle here. That will look something like this, where h is the height. This length down here is half the side length, and this length over here is the slant height. So the height, the slant height, and the side length are related in this way, is that I can make a right triangle that I could then use to find information I don't know. Let's plug in other things I know. This one said that it was a square that's 20 by 20. Sorry, my bad. I read it wrong. 30 by 30. And the height here in red, that's 20 centimeters. So the height in red is 20 centimeters. So this is equal to 20. This would be equal to half. So this here would be 15 centimeters. So I can find the slant height. Now I've been saying that we need the slant height to find the surface area. But let's see why. What if I took my pyramid here and I cut each lateral edge and I peeled it sort of like a banana? I peeled this edge out, I peeled this edge out, this face out, and this face out. And what I would get is a shape that would look like this. I would get my square here. I would get a lateral face right here, a lateral face right here, and a lateral face here, and the last one right here. The height of each of these is L. This here is L. So I look, each of those triangles, I know the slant height. And then this here is the side of my square. So if I know the side length, 30, and I know L, I think I'm going to be able to solve this, because this is the area of a triangle, area of a triangle, area of a triangle, area of a triangle. That's just the area of a square. So look, I replace the numbers I know. S, or the side length, is 30, so 30, 30, 30, all the way around. So the area of the square is 30 squared, or 900 centimeters squared. So I have one of the things I need. It's kind of important, so I'm going to underline it. To find L, this triangle that I constructed way back at the beginning of this is the one I need. The height, the slant height, and half the side length form a right triangle. And this right triangle, if I'm looking for L, I can use a squared plus b squared equals c squared. So 15 squared plus 20 squared equals L squared. So 15 squared and 20 squared, I believe, is 225, and 400 equals L squared. 625 equals L squared. Square root both sides, I get L to be 25 centimeters. And I use that to find the area of each triangle. The area of each triangle is going to be 1/2 base times height. Well, the base is 30. The height of each triangle is 25 because the slant height is 25. So base is 30, slant height is 25. Again, the area equation for a triangle is 1/2 base times height. So when I plug this in, the area of the triangle is going to be equal to 15 times 25, 375 centimeters squared. Now, I found the area of the triangle. I found the area of the square. I have 4 triangles and 1 square in my surface area. So the surface area here is going to equal 900, the square, plus 4 of the triangles. 4 times 375. And the surface area will be 2,400 centimeters squared. And this is how I would have to do it if I didn't have a formula. I would take my shape, I would cut it into its net, and peel each face. I would have to find the slant height using the right triangle, so I could find the area of each triangle and the area of the square, and then add them together to be the surface area. Now, after doing this multiple times, we found a formula that pretty much works for any single regular pyramid. And it does have to be a regular pyramid. Because if it's not a regular pyramid, this formula doesn't work. You're going to have to make a net. So, what it says is the surface area of a regular pyramid is the base area plus 1/2 the perimeter times the slant height. So, the base area I get is just the base area, but it's 1/2 of the perimeter times the height. And just like I showed yesterday with the math, essentially what we did was we pulled out L and said, hey, I'm adding side 1 plus side 2 plus side 3 plus side 4, so it's the perimeter of the base. So if I know the perimeter of the base, I know the area of the base, and I know the slant height, basically I plug them into my formula. And from here on out, my whole goal is to find one of those 3 pieces of information, plug it into the formula, and solve. If you don't know how to use the formula, you're going to have to do it like this. Make a net and solve. This one is a little bit challenging, but I think we can handle this. First of all, I'm not asking for the surface R of the regular hexagonal pyramid. I'm asking for the surface area of the regular hexagonal pyramid. Sorry about the misspelling. That is supposed to be area. So, when I look at my shape here, the base has been drawn for me as a hexagon, and it's really important that I kind of look at it, so I'm going to redraw it up here. Alright, I also see in my picture there that the slant height ends up being 14 feet. So let's just look at this here. I'm first of all going to write down that surface area equation that I'm going to be using. Base plus 1/2 perimeter times the slant height. I notice I already have the slant height. That's 14 feet. So I don't have to worry about that right triangle thing I did in the first part to find the height or the slant height. So now all I have to do is worry about finding the base area and the perimeter of the base. So if I look at the base, this hexagon, it's a regular hexagon. So finding the area of it is going to be 1/2 the apothem times the number of sides times the side length. So the apothem here is from the center of my polygon to the side at a right angle. Oh wait, I have that. That's 5 squared root of 3. So I have the apothem, it's 5 squared root of 3. The number of sides, well, it's a hexagon. There should be 6. And the side length, they tell me is 10. Wait, whoa. I can find the area of my shape because I have the apothem, the number of sides, and the side length. Well, yeah. So basically, to find the base area, capital B here, all I have to do is plug in what I know into my area equation for the regular polygon. So the area equals 1/2 the apothem, 5 squared root of 3, times 6 times 10. And then I plug it into my calculator and solve. Alright, that's what I get for my area. And I'm going to put it over here for my calculation of surface area. Capital B I now know is 259.81 feet squared. So if I look at my surface area equation, the whole goal of this is to find the surface area. I now have B. I calculated by finding the area of my base. L was given to me in the diagram, so I just wrote it down. Now all I need to solve is the perimeter of the base. And the perimeter is the length along the edge. Well, if it's regular, all these lengths are the same. And each of them are 10. So the perimeter is 10 plus 10 plus 10 plus 10 plus 10 plus 10, or 6 times 10. Either way, you should get 60 feet. So wait, I now have my perimeter. I now have my base area. I now have my slant height. Plug it in. Surface area equals 259.81 feet. Let's worry about the units at the end. They're all in feet, so we should be good to go. Or feet squared, I should say. Plus 1/2 60 times 14. Add that together and solve. And if you add correctly, that's what you should get. So, if you've been noticing how I've been trying to solve these problems, what I've been doing is I've been trying to take it step by step. I know what the equation is I'm trying to plug stuff into right at the beginning. I plotted it up there. Then I said, of the 3 pieces of information I need to find surface area, which ones do I have? And I looked. Well, I had slant height, but I didn't have the base area or the perimeter. So I chose one. I could have started with the perimeter, I could have started with the area, and I solved for it. I found the area of that hexagon, so that's like kind of like a separate problem. I just found that area. Once I found that area, I put it under B. And I said, alright, I have B, I have L, but I still need the perimeter. So, I found it real quick. I looked for it and found it. Now that I have L, B, and P, I plugged into the equation and I solved. So this is a little bit work intensive, but it's not that bad, as long as you take it step by step. Now, the next shape we're looking at isn't a pyramid anymore. It's going to be something that's not a polyhedron, because not every single surface is going to be a polygon. It's a cone. One surface will be a circle, and the rest will be this shape. This is still the lateral surface, but I don't know what to call it anymore, so I'm just going to call it the lateral surface. It's also officially its name. This here is my base still. And this, the corner where the lateral surface kind of meets at the top, is still the vertex. Just like before, the height of the pyramid, while they usually give that to me, isn't necessarily what I want. I want the slant height from the edge of the base to the vertex. I don't want from index finger to index finger. That's the height. I need the slant height to find surface area. And again, I might be doing that right triangle type stuff. But let's look at the equation. Now, the equation for the surface area of a cone, I'm going to write in blue up here, right underneath the surface area equation of a pyramid. And when I look at the equation, surface area equals base plus 1/2 circumference times slant height. I notice that the only difference from the pyramid to the circle, or sorry, the cone, is that instead of using the word perimeter, I use the word circumference, meaning the distance around the edge. So essentially, it's the same stuff we've been doing. However, because it's a circle, I know what the area of a circle is. That's pi r squared. And I know what the circumference is. That's 2 pi r. So plus 1/2 times 2 pi r L. Wait, 1/2 and 2 cancel out. So another equation that I sometimes use instead of this top one is this one here, which is the other equation your book gives you. But this one for a cone, I believe, is a little bit easier. Because here you had to find the base area, you had to find the circumference and the slant height and plug it in. Here, if you know R, the radius, and you know L, the slant height, you plug it in, you're done. A little bit less intensive on the work side. It's actually slightly not as complicated. So, let's look at a problem for a cone. In example 3, it says find the surface area of a cone if it has a radius of 7 meters and a height of 24 meters. So I drew a cone, I labeled R, I labeled H, and I labeled L, where they're all located. And right away, I see something. Before I even draw or put in what I know, I notice that I have a right triangle. And anytime I see a right triangle, I know that I'm probably going to use it, so I'm going to just quickly separate it here. The radius, the height, and the slant height. Now I look at my problem, and I see that I'm given the radius. I'm told it's 7 meters. I know the height is 24. Wait, so I know R is 7, and I need L, because if I look at my equation, to find the surface area, R and L are the two things I need. And it's a right triangle to find L. A squared plus B squared equals C squared. So 24 squared plus 7 squared equals L squared. I believe 24 squared is 576. 7 squared is 49, and that's L squared. Those two add together to be 625. So L is 25 meters. So I look, I have L is 25 meters. Wait, I know L, I know R. Yep, at this point, it's just plugging into the formula. I'm looking for the surface area, so that's equal to pi r squared, which ends up being 7 squared, plus pi times 7 times 25. So the surface area is 49 pi plus 175 pi, or when I add those two together, I get 224 pi meters squared. I'm fine with that answer because it's a nice, concise number. It looks nice. It's exact. It's a better answer than if I plug it into a calculator. However, I would also accept this answer. The surface area is approximately equal to 703.72 meters squared. Either answer, I'd prefer the pi unless it says give me to the nearest hundredth or so on and so forth. So I think surface area of a cone is a little bit nicer to us because this equation only requires me to know R and L. I don't have to separately calculate the base area or the circumference and plug it into the equation. I can just find R, I can just find L, plug it in and solve. Now, what if they ask me a little bit of a tougher question? What is the lateral area of a right cone with radius of 3 meters and height of 4 meters? So, right away, they tell me R equals 3 meters, H equals 4 meters, and I don't know L. Now, before I go and find it, they asked me a different question. They didn't just ask for the surface area, they asked for the lateral area. So let's think about this. If I'm looking for the lateral area, I want all the area except for the base. Wait, I want all the area except for the base. So to find the area of this top portion, I don't add the base. So when I look back at this equation, it's base area plus 1/2 circumference times L. So this equation, if I'm looking for just the lateral area, if I got rid of the base, that would be the lateral area. Because there's only two areas in a cone, the lateral area and the base area. So if I get rid of the base area, 1/2 CL is the lateral area. And if I look at how 1/2 CL changed, that means the lateral area is going to be pi r L. So lateral area for a cone is equal to pi r L. So I look, I have pi, I know it's something around 3.14. I know where the radius, they told me. If I know L, I know how to find the lateral area. I do L times R times 5. So I look at this. Yep, I do need to use that right triangle again. L, 4, and 3. So 3 squared plus 4 squared equals L squared. 9 plus 16 equals L squared. L squared equals 25. Therefore, L is 5. So I now know L is 5 meters. To find the lateral area, pi times 3 times 5. 15 pi meters squared, or 47.12 meters squared. And then this would be the area I'm looking for, lateral area. And there we go. So, to find what I'm looking for, I kind of use the idea of what this equation is telling me. The equation is telling me if I take the base area plus all the lateral area, I get the surface area. So if I'm looking for just the lateral area, I'm looking for just the second part. If I'm looking for just the base area, I'm looking for just the first part. And there we go. Again, find what you need, plug it into your equation, and solve. You might have to do some scratch work off to the side to get to where we're actually trying to solve. And that's all I have for this section. This is it for surface area until I look at spheres. So, till next time.